Yeah, so in the last lecture, we discussed, if you remember, we discussed the distributions. Okay, so now we continuing our topic. So now there are two categories. First one is the parametric and second one is the parametric. When we talk about distribution or if we talk about the learning, so you may arrive two types of two category in the statistical procedure. First one is the parametric and second one is the non-parametric. Yeah, so in the, do you remember in the last class we discussed a distribution and one of them distribution we discussed about the Gaussian. Yes or no?
Yes, sir.
Distribution. Clear. So we continuing our as per the syllabus. So now parametric, there are two terminology, parametric and non-parametrics. And see, there is no widely acceptable definition of a non-parametric. So if you see the different sources, they will have the different definition for the non-parametric. But one thing is common in the non-parametric, that is the distribution or the data doesn't have any form. Clear. So there is no widely definition and quantities such as if you see mean, standard deviation will be used in case of the parametric when we talk about the samples that are following parametric pattern. Clear. So you will see the three terminologies, parametric, non-parametrics. In the non-parametric, you will see the different sources have different way of defining. But one thing is common, no form of data or shape, or you can say no shape of data, no exact shape, or some data is having some particular shape and some doesn't have. Clear. So I will dictate the correct definition because in the next lecture we will learn the learning algorithms. So in that case, it will be helpful to you. And I will correlate this with the previous lecture as well. So parametric statistical procedure relies on the assumptions of the shape of the distribution. Okay, so they rely on the shape of the distribution and non-parametric just the opposite. So sometimes in the parametric distribution, if you remember from the previous class, we have Gaussian distributions. If you remember, we have this kind of distribution, if you remember, or this was the zero mean. So we have some distribution from -5 to 5. Do you remember previous class? Gaussian. Okay. So this is, or you can say the normal distribution, a normal distribution. So in the parametric, we can say the assumptions about the shape of the distribution. Okay. Uh, and sometimes they will use mean, standard deviation things in the distribution. Okay. This is I have already given. In this, the mean value is the central tendency. The mean value is the central tendency. Okay. So someone talk about the parametric distribution or parametric. See in the, if you search Google, you will see different things. Uh, Parametric test, parametric learning, parametric method, parametric distribution. So don't confuse. So we are discussing the common terminology that is parametric and that is applicable for all of them, whether it is parametric test or parametric learning or method or distributions. Okay. So parametric distribution rely on the assumptions about the shape of the distribution. Okay. You can say the normal distribution that we have discussed yesterday in the last class. Okay. And the mean is the central tendency in case of parametric distribution. Clear? So this one is clear, I think. You will have a parametric test as well. You have the parametric learning, parametric methods, and parametric distribution, just this one that we discussed. Clear? And one example of the parametric distribution is the students' T sets. One example of the parametric distribution is the students t sets. So in the lab assignments I have given you a question in which you need to plot students t shape. Okay, so you just need to take some random data and using the inbuilt library that is available in the Python, you will just see what pattern your data is following when you are obtaining the students t sets. Clear? So student t sets is just similar to the Gaussian distribution that we discussed in the last lecture. It is just a different kind of distribution like Bernoulli, and we also have chi-square distribution, Bernoulli. So similarly to that, we also have students t set. And one more thing is analysis of variance. This is in your syllabus in the fourth module, or I think no, it is in the third module, analysis of variance, ANOVA. Okay, so we will discuss that in detail in that lecture. So it is clear what is parametric. Parametric.
Yes, sir.
Clear? So they rely on the shape of the distribution. Yeah. And the mean is the central tendency, and the examples are the students t set, analysis of variance. Okay. And the non-parametric is just the opposite. So in case of non-parametric, they rely on no or few assumptions about the shape of the parameter. Okay. So they rely on no, that means there is no assumptions, or there may be little assumptions about the shape of the distributive parameters. Okay. And the most practical purpose, however, one might define non-parametric statistical process as a class of statistical procedure that do not rely. So I'm saying again, some sources will tell you do not rely, and some sources will tell you rely on no or few assumptions. Okay. And in this case, the central tendency is the mean value. The central tendency is the mean, sorry, it is median value. Central tendency is the median value. And the examples are Mine, Whitney, Wilcox test, or this one. Okay, so this is not in your syllabus. And the one question arise in your mind, suppose you are working on some topic, maybe some research based topic, and you have some kind of data. So what do you think, it is a parametric or non-parametric? Any answer? Or just like in the first class, I gave you an example of house data. If you remember, we have some houses. Okay, so we have some details regarding their rooms, number of rooms, okay, area, okay, and their rate, that means the price of the house. And one more parameter you can have, it is furnished or non-furnished. So suppose you are having these three attributes: number of rooms, area, whether the house is furnished or non-furnished, and their price. What do you think? What kind of data is this? It is parametric or non-parametric?
Sir, parametric.
Okay, parametric. Just one more example. See, any other student? Okay, if those who are telling it is parametric, I have one question. Can you justify which shape it will follow? Okay, one more example. This will be more easy. You are having two dice. You are having two dice. Okay. Or where outcome is the 1 2 2 6. So if you are throwing two dice, and then the sum of the outcome will be from 2 to 12. Am I right?
Yes, sir.
Okay, I'm just adding some space. Okay, so if you are having two dice, okay, so sum is from 2 to 12. I'm creating a table here. Okay. Where X is the sum and probability, then cumulated probability. Okay. So 2, 3, 4, 5, 6, 7, 8, 9, 10, 12. Sorry, 11 and then 12. Okay, 11 and then 12. So 2. What is the probability when the sum will be 2? Just like this, 1 comma 1. Yes or no?
Yes, sir.
You know, so it will be 1 upon 36. Am I right? Okay. And what is the probability when sum will be 3? It is 1 comma 2 or 2 comma 1. Am I right?
Yes, sir.
So it will be 2 upon 36. And for 4, it is 1, 4 के लिए 1, 3, 3, 1 and 2, 2. So it is 3 upon 36. Am I right?
Yes, sir.
It is 1 upon 36. Then it will be 2 upon 36 and so on. Okay. So you can find the cumulative probability. Okay. So when you plot this from the last lecture, if you plot this x values, and this probability, you just have the which kind of plot you have. It is 1 upon 36, then 2 upon 36, 3 upon 36, 4 upon 36, 5 upon 36, and then 6 up 6 nahi aayega, I think. Then this kind of pattern you might have. Am I right? It is 12, it is 2, 3, it is 11, it is 10. Am I right? This kind of pattern you might have, dear
Yes.
friends. Yeah.
Yes, sir.
Yeah, so this kind of pattern I think is following some kind of shape. You can say it is just like a similar to the Gaussian shape if you see. But in case of house data, it is very difficult to predict. Am I right? Yes or no?
Yes, sir.
One more example. I have a very good example actually. Now, instead of throwing, but it will be difficult. Instead of throwing 2 dice, I am throwing 3 dice. Clear? So the sum can be from 3, 4 up to 18. Am I right? Yes or no? Yes.
Yes, sir.
Sir, can you repeat this अभी जो आपने बोला?
Yeah. See, instead of throwing 2 dice, I am throwing 3 dice. This time you are in the data science, we look into the data. Clear? So now you're just critically thinking. So first we throw 2 dice and we analyze what kind of a pattern your data is following, what kind of shape. Clear? Now instead of 2 dice, I am throwing 3 dice. Clear? So when we throw 3 dice, what will be the sum of the all the 3 dices? It may be 3, it may be 4, up to 18. Yes or no?
Yes, sir.
And the possible outcomes, 6 into 6 into 6, I think 216. If you if you studied the probability in earlier semesters, 3 dice possible outcomes 216. Am I right? Clear. Okay. So now what is the probability when sum is equals to 3? It is just a one case, 1 comma 1 comma 1. So it is just a 1 upon 36. Sorry, 1 upon 216. Yes or no? Now,
Yes.
what is the probability when sum is equals to 4? Sum is equals to 4, that means 1 plus 1 and plus 2. How many possible ways are there to obtaining this pattern? 1, 1, 2.
3 है sir.
Yes, 3. Okay, good. 260. Now sum is equals to 5. 1 plus 1 plus 3 or 1 plus 2 plus 2. Yes or no?
Yes sir.
So how many possible outcomes are there?
6.
Okay, 6. Okay, so 6 is there. So whenever you just plot all these things, when you plot all these things, you will see this curve. This curve will exactly follow it will go something like this. Okay? And again, when you increase the dice, then we'll again go in this way. So whenever you increase the number of dice, it will become like this. So you can see this throwing dice for n number of times will follow some kind of a shape, or this shape is, you can say, it's just similar to the normal curve, or you can say the Gaussian curve. So in that case, we can predict, oh, this might be the parametric. But in case of housing data, it is difficult to predict. Clear? So this is the point I have written here for a research perspective. To make a choice between parametric and non-parametric test is not easy for a researcher conducting statistical analysis. Okay? So it is very difficult for a researcher to decide. It is not easy. Clear? This is fine.
नहीं sir, एक बार फिर से समझाना.
Okay, what I am saying is that I have taken two examples. One is housing price data and second one is throwing dice. So first time we were throwing 2 dice, second time we were throwing 3 dice, then we will throw 4 dice and 5 dice and so on. So when I throw 2 dice, I saw this kind of pattern is following, this kind of shape. When I throw the 3 dice and I plot the probability, I show this kind of shape my data is following. Okay. So what I am saying is that in case of throwing our dice, we can predict, or we can say our probability distribution is following some kind of a Gaussian distribution. You can see from the previous lecture, we plotted a Gaussian probability density function of Gaussian. So we have this kind of curve from the previous class. It is just like this. Clear? So what I am saying is that for throwing our dice, we can say it is just following some kind of shape. So it may be a parametric. But in case of housing price data, it is very difficult to say whether it is parametric or non-parametric. Clear? So for the researcher point of view, it is difficult, or it is not easy to justify whether it is a parametric or non-parametric. Clear?
Okay sir.
Yeah. Once again, suppose you are having some data. ठीक है, and you want to apply your learning algorithms for some kind of activity you want to apply. So which kind of learning algorithm you will apply? Which kind? So it is difficult for us to make a choice between parametric and non-parametric. It is not an easy task. So you have to go through all, you have to have a good knowledge of data analysis. Okay. So one more example I'm trying to convey. Yeah, see. So let us be have a sample of critically ill patients. Just a minute. Sorry. Yeah. So we have a sample of critically ill patients. Again, one example. And the sample contained 20 females and 9 male patients. So we have some data, 20 females and 9 males. Clear. Okay. And the thing that is the length of stay. The length of stay in the hospital. Okay. We would like to compare female and male. Okay. Now what is given to us? It is given to us given data. Mean of female is 60 days and median of female is 32 days of stay in the hospital. I think, am I audible? I think, am I audible?
Yes, sir.
Yeah. Clear. So we have some data. You can say 20 females and 19 males. And the variable of interest is the hospital length of stay. Clear. It is given the distribution of female is strongly right skewed. Why? We are just telling you. Clear. So it is given that the mean of the female for staying in the hospital is 60 days and the median value is 32. Clear. But in case of a male, it is almost the same, but the mean and median almost the same. So you can say this type of data is called right skewed. Means the mean is usually not in the middle. When mean is not in the middle, it is called right skewed. So in case of female data, the mean is not in the middle. Okay. So when we compare two groups, their medians are quite similar, but their means are very different. So this is the case where the assumptions are normally associated with a parametric test is probability not reasonable. So you can say this kind of, you can say parametric procedure would be a more appropriate in this case. Okay. So you have a, if you are having a this kind of data, so what kind of procedure is more appropriate between the parametric and non-parametric? The non-parametric procedure will be the more appropriate because the data is right skewed in case of female. Right skewed means the mean is not in the middle. Clear? So median value for the both the data is almost the same, not exactly, but the mean value are quite different. Clear? So this is once again an example, but the previous one was we were plotting a graph, but in this case we are not plotting the graph. We have a different kind of data. So this is clear.
Yes, sir.
Clear, because in the start I have already discussed the central tendency in case of parametric data is the mean, and in case of non-parametric data it is median. Clear? Okay. So this is your parametric and non-parametric from the statistical perspective view. Now I am telling from the learning points of view. So just Is there any question? Is there any question? Okay, no questions. Okay. So now from the learning perspective, we will see the parametric and the non-parametric. So see, in most of the machine learning algorithms, what we have, yeah, we have some kind of data. You can say we have some kind of data X. Yeah, and the goal is what? The goal is to predict Y. The goal is to predict Y. Clear? We have some kind of data X, and the goal is to predict Y. And for this prediction, we will design some function or some model. You can say in learning terminology, instead of function, we called it model. But from the mathematics perspective, we called it function. So the goal is to predict Y. When we have X using some kind of model or function. So this is just a learning, you can say. Clear? The algorithm learns a target mapping function from training data. So this kind of data, you can say it is a training data. Okay. It is a training data again. And using these two, we will predict this one, or sorry, we will design this function by, and using this function, we will obtain our data for some unknown values. Clear? So using the given data, we will obtain this function, and using this function, we will predict Y value based on the unknown parameter. This is clear. What does learning means? Hello?
Yes, sir.
Okay. So in case of learning, we have some kind of data. Using that data, our goal is to design a model, or you can say a function. And using that function, we will predict the value of the unknown data, just like housing price data. In case of housing price data, we were having some house data and their price. Using that, we will design a model, and using that model, we will predict the price of the house whose price is not given, but other data is given. You can say the X values are given, and we need to predict the Y's value. Yeah. So this is, you can say this is a simple learning. Clear? In the next lecture, we will discuss the category of learning. It is supervised or unsupervised. Clear? So a learning model that summarizes data with a set of parameter of fixed size. Parameter of fixed size is called parametric model. Clear? So a learning model, this f here is called model, you can say, or function. Clear? So a learning model that summarizes data with a set of parameters, of fixed size is called parametric model. Clear? So no matter how much data you have, it will not change the accuracy. It will not change its mind. Clear? So in case of learning, parametric means the learning model that summarizes data with a set of parameters of fixed size. Clear? So in this algorithm, what we need to do, we need to select a function as discussed above and learn the coefficients for the function. I can give you a just simple example. A plus B0 x0 plus B1 x1 and so on, Bn xn. So these are, you can see the coefficients, this learning coefficients. Okay. So learn the coefficients from the for the functions from training data. Okay. Clear? So it is given select a form for the functions. So here I am taking the linear function. If you see here, it is a linear equation. It can be quadratic. You can say a0 plus a1 x square, something like this. So I have taken the simplest example. So we will select some kind of function, and then we will learn the coefficients for this functions from the training data. Okay, and that coefficient will be used for testing data. Clear? So these are the examples here. Logistic regression. I think this might be all these are new for you, I think. Have you heard anything?
Nice.
Okay, no problem. We will discuss according to our syllabus. In our syllabus, we have supervised. In the next lecture, we will discuss supervised and unsupervised. Okay. So in case of supervised learning algorithm, we have regression. REGRESSION regression. Unsupervised, we have clustering. CLUSTERING. Okay. So we have clustering. Okay. This perceptron is just a simple neural network. I have taken the tutorial in IIT Indore for all these subjects, all these topics. So I remember perceptron. This is called LDA, linear discriminant analysis, neural network, Navier. Okay. But in your syllabus, we have supervised, unsupervised. In the supervised, we have regression, okay, and classification. Okay. And in case of unsupervised, we have clustering. Okay. So we will see according to the syllabus whether you have a neural network or not, all these things. Okay. Okay, so I think this is clear. The parametric model means you have a fixed size of parameters. Okay, so your goal is to select a functions and learn the coefficients of that functions. Okay, and these are some theoretical things. Benefit of parametric. You can see these algorithms are simple. These are faster than the non-parametric, and they require less data. Okay. And limitations, they are highly constraints. Constraints you can see specified form of data. Okay, so I have already told you your data must have a specific form. Okay. The methods are more suited to simpler algorithms. So ये जो algorithms है ना ये the regression or linear discriminant, these are the simpler algorithms. And there is a two terminology. I'm sure you are not aware. Poor fit and overfit. Have you heard about this? Okay, I will tell you. Just a minute. See, suppose you are having some data. Okay, okay. You are having this data. Okay, this is x values, this is y values. Okay, and this is your function f. This is straight line. Sorry, this is straight line. So these are called the errors. These are called the errors. So in case of underfitting, or you can say poor fit, our training data will not fit to the our training model of function will not fit to the training data itself. So there will be the error. Or you can say the large error. And in case of overfit, what will happen for the same kind of data? Our function or model will be in this form, or like you can say this. So you can say your model is exactly fitting all the data points. Am I right? Yes or no? Friends?
Yes, sir.
So which one is simpler? This one is simpler or this one? This one is simple and this one is complex. What is the problem here? It is underfit. Some of the data points. It is okay if some of the data points are not exactly fit, but but the error will not be too much. In case of overfitting, what will happen? All the data points will exactly fit. So what happened in this case? sometimes they also fit the noisy data as well. Noisy data as well. So what happened whenever you have some unknown points, suppose this is unknown point. So it will not give a good accuracy when we test your model on unknown data. Okay? Because it fits the noisy data as well, overfitting. So it is a complex one. So the two terminology will be used, poor fit, or you can say underfit and overfit. So we will discuss in detail. I will give you the example in the live and in the consecutive lectures as well. So if I have not given you this example, then you have to remember what is poor fit or overfit. But now you can see poor fit or underfit must be like this whenever it doesn't fit on the training data well. Overfit means it fits on the training data well, but it fits so well that it is not fitting well on the testing data. Clear? So it is just a overfit. Clear? So just again 1 or 2 minute break and just ask your doubts till now. Parametric learnings. Parametric learnings, we have some kind of function. Clear? And we need to select the coefficients, or in the parametric learning we have fixed parameters with the set of parameters of fixed size. These are simple, these are faster, these require less data. Some examples are regression, perceptron, neural network, linear discriminant analysis, LDA. Okay. But in case there is a problem of underfit, okay, overfit for the next for the non-parametric, not for here. So this is having the problem of underfit, and one problem is that your data must have a specified form. Okay. And these are more suitable for simpler one. Clear? There is any question till now? Is there any question? No? Hello?
No, sir.
Okay.
No question.
No. Now next one is the non-parametric. In case when we talk about the learning. So non-parametric methods are good when you have a lot of data. So in this case, you are having a lot of data and no prior knowledge. You don't have any prior knowledge. And when you don't want to worry too much about choosing just the right feature. So your goal is not to just choose the right feature. Clear? So you have a lot of data with no prior knowledge, and you are about not to worry too much about choosing the right features. Okay. So one good example I will show you in research paper as well. So non-parametric methods seek to best fit the training data in constructing the mapping function while maintaining some ability. So see, they are trying to best fit. They are trying to best fit the training data. Best fit the training data and some ability to generalize the unseen data as well. So they are able to fit large number of functional forms. So in case of parametric, the functional forms are limited, but they are able to fit a large number of functional forms. Okay. So for non-parametric, keep in mind if you have no prior knowledge, okay, you don't want to worry about choosing the right features. Okay. And some examples are k nearest neighbor, decision tree, support vector machine. So these two I can show you in the research paper as well. Do you want to see how they used nearest support vector machine? Hello?
Yes. Yes, sir.
Okay. Okay, I will show you a paper, research paper. Just a minute. Mm. Okay, so research scholar, Google. Okay. Yeah, so density, this one, this paper. Okay, so okay, view PDF. I need to download actually. I do not have in my system. He's my friend from IT Indore actually. Okay. Oh, sorry, it is recorded and it illegally I am showing this actually. Okay, so what I was talking about, support. See here, support vector machine. So support vector machine, K nearest neighbor, Naive neural, these are the learning algorithms. And in his case, for mammogram classification, mammogram is just the breast cancer, breast images for cancerous patients. So he used a support vector machine. He used support vector machine, SVM you can say. SVM he used. Okay. So he doesn't show the mathematically here, but he used a support vector machine SVM for mammogram classification because he have mammogram images and he doesn't have any prior knowledge about the mammograms, and there are large number of mammograms are there, and he want to classify whether the mammogram is benign or malignant, whether it is cancerous or non-cancerous. So he used support vector machine. Clear? So this is just an example. In the research paper itself, they use these kinds of learning algorithms. Is it fine?
Yes, sir.
Okay. Now I will give you the example of a k nearest neighbor. Suppose you are having data. You are having data. Okay. What happened in the k nearest neighbor? Uh, in case of a k nearest neighbor, that will make prediction based on the k most similar training pattern for a new data instance. This is simplest one you can say. So based on what k most similar training pattern. So they will take some guidelines for judging the similarity. Okay, because similar. So what is the criteria to check whether it is similar or not? So they will have some statics for checking whether they are similar or not. So they will take k most similar. K most similar, and k will have any value. You can have 64, 12, 8 according to your data. Okay, so the method does not assume anything. We are not assuming anything about the form of the mapping function. You can see we are not assuming anything. We are just having the data and we are having some criteria to check the similarity. It can be anything in terms of statics. Okay, it may be the distance or anything else. Okay, and we are choosing the case most similar patterns. Clear? So this is the simplest one, you can say the nearest neighbor, k nearest neighbor. Clear? And what are the benefits? I think I have a lecture. Just a minute, I need to cross check timing. What is the timing? It is 10:42. Just a minute, 10:42, 11:35. Okay, fine. Yeah. So benefit, they are flexible. You can see flexible, no assumptions, and can result in higher performance as well. Limitations, you need a lot of data, they are slower, and overfitting. Sometimes you may have overfitting. That means training data fits well, but testing data will not fit well. So this I have discussed. This is overfitting. Clear? So this is for today. So anything you want to ask?
सर इस सब्जेक्ट का कोड क्या है?
Sorry.
What's the code of this subject?
Okay, just a minute. Code. I will stop the recording.
सर एलएमएस पे है क्या कोई सब